Question number 17 says that prove that the function f given by fx equals log of mod cos x is decreasing on this and increasing on this. Okay, this time we have an interesting function. We have modulus of cos x. Let's talk about fx equals log of mod cos x. So f prime x, what will that be equal to? Now log of something, the derivative is 1 upon mod cos x. What about the derivative of modulus cos x? Now derivative of mod x is slightly interesting. That is simply mod x upon x. Okay, where the derivative will not be defined when x is 0. Okay, so derivative of mod something will be mod cos x over cos x. This is what I'll get. But still, the chain rule says that derivative of cos x is also required. What is that? Minus sin x. Now, the important thing that I've used over here is derivative of mod x, which is mod x upon x, except when x is equal to 0, right? And this is not difficult. This is pretty simple. You can observe it directly from the graph of mod x as well. The derivative gives you the slope, right? The derivative gives you the slope. This is a line y is equal to x. The slope y prime is simply 1. This is a line y is equal to minus x. The slope y prime is equal to minus 1. That's what you can observe, right? So 1 is actually equal to mod x upon x over here since x is greater than 0, right? This is equivalent to this. And minus 1 here is mod x upon x, which opens that mod x in this particular region will open as minus x. Minus x upon x, which will be minus 1, and this is 1. And that's what you can observe. And this is the way in which we can kind of deal with it. But this is what I get. If you observe cos x and cos x will get cancelled, and this is minus of sin upon cos is tan x. Okay. What about the first quadrant? For x belongs to 0 comma pi by 2. In this interval, tan x is positive, so minus tan x will be negative. This gives me f prime x will be less than 0. Okay, this tells me that f is decreasing in this interval. And was that what we wanted to prove? The function this given by this is decreasing on this interval. Yes, this is what we wanted to prove. That's the first part of the question. The second part says that for x belongs to, what do we have over here? 3 pi by 2 comma 2 pi. This interval. For x belongs to this interval, what do we have? In 3 pi by 2 comma 2 pi, this is the fourth quadrant. Tan x is negative, but minus of tan x will be positive. This tells me f prime x will be greater than 0, implies f is increasing over here in this interval. This is what we note. Since this is the fourth quadrant implies tan x will be negative. Therefore, f prime x, which is minus tan x, will be greater than 0. Okay, that's the complete solution and the proof of this question over here.